47, 48, 49, 50, 51. All right, we need to cut it right here. Smoked the power supply, fried my leads. Guess I shouldn't have cut that while the power was on. Hi, I'm Robert Donlin, and this is Lights by the Sea. If you're going to get yourself into the do-it-yourself Christmas lighting hobby, we need to first talk about low-voltage electrical safety. And before we talk about electrical safety, we need to have a little understanding about electricity. I love electronics. I started my career in electronics and spent 8 years in the Navy as a nuclear electrician. After that, I became an industrial controls engineer and did that for about 10 years before moving into management. Sequencing, buying pixels, and building controllers are all important. However, the most important aspect of this hobby is safety. Let's start by reviewing some electrical terms. We'll use the analogy of water flowing in a pipe to describe electricity, and we'll start with voltage. In simple terms, we can compare voltage to water pressure in a pipe. The greater the water pressure, the more water that flows through the pipe. Volts is the pressure needed to push electrical energy, the energy that we will be using to drive controllers and light up our pixels. In this drawing masterpiece, the pump creates pressure, which creates flow. If there is a restriction in place, it resists the flow. On the electrical circuit side, we have a power supply that converts 120 volts to 12 volts, which provides current to our pixels. The resistor resists current. In a circuit, the greater the voltage, the more current that can be pushed to do the work. The current is measured in amperes, abbreviated as amps, and it is the amps and not the voltage that does the damage when electricity goes astray. It takes very little amperage to kill, as little as 20 milliamps. That's 20 thousandths of an amp. That's not much, especially when we are working with 55 milliamp pixels. Another important term is resistance, which is measured in ohms, and tells us how easily electricity can move through a conductor. In our hobby, our conductors are generally stranded copper wire. Poor conductors are called insulators, because they resist the flow of electricity. That's why we use electrical tape or shrink tubes on our connections. The last term, I'm sure you heard of, is ground. Electrical current always flows from areas of higher voltage to areas of lower voltage. The earth, the ground, has 0 volts. Therefore, electricity, no matter the voltage, always tries to go to earth or ground, and it always follows the path of least resistance. Now let's talk about some of the dangers of electricity. They can be categorized into 3 areas: electrical shock, flash burn, fire, and explosion. Electrical shock symptoms can range from minor irritation to cardiac arrest. The most common symptoms are loss of muscle control or contraction, and can cause you to grasp, preventing you from releasing the source of the shock. That's the same reaction I get when I see my cart and ordering pixels. Electrical current may cause many different effects on the human body. Symptoms include minor irritation to paralysis. Higher current can cause severe surface or deep internal tissue burns from the heat generated by current flow, and worst case, cardiac arrest or death. The second source of electrical injury is flash burn or arcing. In our low DC voltage hobby, this is not as likely. However, since we have 120 volts or 240 volts on the power supplies, it can be possible. The danger is that if a short occurs, a flash or arc can happen, and that will cause eye injury or burns from sparks. Arcing can also be a source of ignition, which brings us to the final danger of electricity: fire and explosion. If things do go wrong and an arc occurs, and flammable material is around, a fire can start. Or in the worst case, an explosion can occur. One of the reasons I would not recommend putting your electronics in a wooden enclosure or on a wooden backboard. Now that we know about the dangers of electricity and how they can affect us, let's talk about some of the precautions and safe hobby practices that we can follow to prevent accidents from happening. Probably the most common exposure we have to low voltage danger is the initial build and setup of our light show. Before powering on your enclosures and props, take a look at all cords and pigtails. If they are cracked or badly chafed, you're looking at a hazard. Replace damaged wiring. Is the plug in good condition? Visually inspect your connections, and where possible, pull on connections to ensure a tight fit. Tighten or attach a ferrule to ensure a tight connection. Be sure to consult with the wire fusing chart when building your enclosures. I'll include a link in the description below. Step 1. Locate the current in amps for your string of pixels. We use the equation 0.055 times 0.3 times the number of pixels to get the amps. For example, 200 pixels running at 30% brightness is 3.3 amps, which will round up to 5. Step 2. Find the circuit length in feet. In this example, we'll look at a 50-foot long pixel string. Step 3. Intersect the current in amps with the length in feet to determine the wire size we should be using for a safe circuit. Before we close out this episode, I want to stress the importance of safety in our hobby. It's easy to get complacent with electricity. Please don't. And at the very least, keep an extinguisher around just in case things go wrong. With some basic electrical knowledge and a good safety talk, we are ready to get into the lighting lab and get some lights that go blinky blinky and flashy flashy. If you'd like to share any of your safety tips or near miss stories, please include them in the comments below. I'll be sure to put any links discussed in this video in the description below. If you like this video, please like it, and even better, share it on Facebook, Twitter, or any other social media outlet you frequent. Please hit that subscribe button to bookmark this channel and receive notifications of future episodes. Once again, I'm Robert Donlin, and this is Lights by the Sea. The best time to plant a tree was 20 years ago, but the second best time is today.